This is experiment number 3. This is about voltage divider. The objectives of this experiment is number one is to be able to familiarize with the operation of the voltage divider. And identify the factors that affects the output of a voltage divider, to be able to demonstrate the basic applications of a voltage divider. In a direct current circuit, the voltages supplied in a circuit is distributed among the resistors connected in series. And in this figure, there are two resistors connected in series, and there is voltage V1 and voltage V2 that distributed in each resistor. And this voltage V1 and V2, when added, it is simply equal to the supply voltage. We may also term this voltage P at total supply voltage, or V sub T, or total input voltage. The voltages V1 and V2 in formula, it could be written as I1 R1. This is also can be written as I times R1, since I1 and total current and current I2, which is the current in R2, are the same. And voltage V2 would be simply equal to IR2. Now, it said that the voltage input, or total voltage, divided by R total is the current in the circuit. We can use that to replace the voltages V1, which is I1 R1, or simply I. And this is the I R2. So replacing this is simply I. So the I is total voltage over R total. We can also express R total in terms of sum of the resistance R1, which is R1 plus R2. This is the equation form. This simply shows that the voltages V1 and V2 is a function of the input voltage and its resistances. The larger, since Bin is usually constant, this is fixed. So we can change the voltage V1, the value of the voltage V1 on the resistance through the resistance R1. And also the voltage V2 may be changed through the resistance R2, since Bin, or total voltage, is usually constant. So that's how a voltage divider works. And if we have a total voltage here being supplied in R1 and R2, the voltage to reduce or increase the voltage in the element R2, we can increase or decrease the resistance to attain our desired output. So meaning if we are going to connect a load across this resistance R2, we can attain a certain level of voltage V out, and that voltage V out is our objective in this experiment. How this output voltage affects when a load is connected across the terminals. If we connect the V out here, the V out here is simply total voltage times R2 over R1 plus R2. That is without load. This is without load. So we can obtain the voltage using this formula. What if we now connect a load, our load across R2? What would happen with the V out? The V out would now become total supply voltage times the resistance. Let's name this as resistance in parallel. Resistance in parallel divided by R1 plus resistance in parallel. So we can see here the current is the current in the circuit is the voltage total over R1 plus R2. Now, when an RL is connected across R2, the current now, let's name this as I prime. This would now be the same voltage supply, but this is R1 plus R parallel. If R parallel is less, that is less than the any of the value of resistors R2 and RL, and so therefore R parallel plus R1 is definitely less than R1 plus R2, and therefore we expect an increase in current in the circuit. This increase in current in the circuit would definitely change the value of the voltage output, and as shown in this formula, there is a change of resistance Rp or resistance in the numerator and the resistance in the denominator. That would definitely become less than the V out without load. Here is the B out loaded, and we expect a drop or decline of voltage output when loaded. In your experiment, you will study this behavior of unloaded and loaded voltage divider and compare what you can realize on how to control the voltage output of a voltage divider. In run 1, you will connect 3 resistors in series. The R1 is what we call the bleeder, and R2 and R3 are our resistances for output terminals. There are 2 resistors connected for an output. We have here an output 1. The output 1 is for low. This is output 1 for low voltage output, and here we have here an output 2 or let's say B out. This is a B out 1 and this is B out 2 for low voltage output. So low voltage output and high voltage output. As you can see, for low voltage output, we have only 2 kilo ohm, and for high voltage output, we have 3 kilo ohm resistance. It shows that the higher the resistance, the higher the voltage we shall realize across the output terminals. So for run 1, this is unloaded condition. The terminals of R3 of the B out 2 and the series of R2 and R3 or B out 1 has no resistance connected. So this is without load condition, and you simply connect ammeter. This is a ammeter. This will measure the current. Measure the current. Here it will measure the B out. This is a voltmeter B out 1, and this will measure B out 2. So you just run the program and get the measured values for high voltage output, meaning R2 and R3 are in series. So this is high voltage output. So high voltage output, and this is the low voltage output. So this is the low. This will measure the low voltage output. So run the program, get the reading of the voltmeter 1, and get the reading of the voltmeter 2. So for voltmeter 1, this is the reading of B out 1, and that would be the highest voltage voltmeter reading, a higher voltage voltmeter reading. Low voltage output is the reading of the voltmeter 2, and of course these are in series, so reading of the ammeter here, reading of the ammeter here, they are just the same. And then stop the program. Stop the program. Then next is load a resistor for the high voltage output. For high voltage output, you will connect a resistor across R1 and R2, and this resistance is equals to, I think, 1.5 kilo ohm. Okay, 1.5 kilo ohm. So a 1.5 kilo ohm is put across the series R2 and R3, and that is a high resistance load. High resistance load. Then observe the reading of the voltmeter. For high voltage output, this is the reading of voltmeter 1. And then the reading of the ammeter, corresponding current for this loading of 1.5 kilo ohm. And then change the value of the load resistance to 800 ohm. Then record the reading of the voltmeter 1 for low resistance load, and then the new reading of the ammeter. Then for this is for high voltage connection. For low voltage connection, we shall connect the 1.5 kilo ohm resistor across 2 kilo ohm. So we shall connect here. We shall connect here. Across the kilo ohm, we have to open, of course you have to open or run to. We shall connect the resistance across the 2 kilo ohm resistor, and the load resistance here is also 1.5 kilo ohm. This is the under low voltage output, because for 2000 kilo ohm resistor, the voltage here across 2000 is less than the voltage across the series combination of the 2 kilo ohm and 1 kilo ohm. So the voltage here is low. So now you remove the 1.5 kilo ohm connected to the output, high voltage output. So this time the resistance is connected to 2 kilo ohm, and then get the reading of the voltage V2. So the reading here is voltage V2, and the corresponding current for this 1.5 kilo ohm load. The next is reduce the 1.5 kilo ohm to 800 ohms for low resistance loading, and then record the voltmeter reading of voltmeter 2 and the ammeter reading for run 1B. For run 2, for the run 2, this is a demonstration of the use of potentiometer in controlling the voltage output of the voltage divider. Here we have this measures the current. This is an ammeter and a voltmeter. In your multisim, you will simply represent this voltmeter using the positive probe, using a positive probe and a negative probe. This is the positive probe and the negative probe. While an ammeter is simply you will simply link uh, a, a clamp meter to measure the the current in the circuit. So the ammeter will read the current, and the voltmeter will read the voltage output in the across the potentiometer. So for run to A, this is an unloaded voltage divider using a potentiometer. Set the value of the potentiometer to 10% of its maximum value, and then get the reading of the ammeter and the voltmeter. So you record the B out here and the reading of the ammeter. For trial 2 of run 2A, this is a high voltage output, meaning the voltage across the potentiometer would be high, and that is only if we increase the resistance of the potentiometer. So increase the resistance of the potentiometer to 90% of its maximum value and get the reading of the ammeter and the voltmeter again. So you record here the B out and the reading of the ammeter. For run 2B, this is a loaded voltage divider. We shall connect a resistance across the potentiometer, and that resistance, the resistance value would be, let's see, the experiment guide, 3 kilo ohm resistance. So 3 kilo ohm, this is a 3 kilo ohm resistance connected across the potentiometer. That is a high resistance load, and the setting of the potentiometer would be so take the meter reading here. This reads the current in the circuit, and this meter reads the B out. So whatever the reading, record that in the initial condition or initial setting. So record here the B out, whatever the reading of the voltmeter. Then record here the current reading, the reading of the ammeter. And if the voltage output drops 8 volts, adjust the potentiometer come up with V out equals to 8 volts. So adjust the potentiometer, but prior to that, see to it that the setting, the initial setting should be B out. B out should be 8 volts first. No? So you set before connecting the 3 kilo ohm, before connecting the 3 kilo ohm. No? Okay. So you set this to 8 volts. When 3 kilo ohm is connected, definitely this 8 volts would drop. There is a decrease in voltage output. Then record this decrease in voltage and record the current reading. Then adjust the potentiometer so that the output would return to 8 volts. So the voltmeter reading here would be 8 volts, but what would be the reading of the ammeter? This is after adjustment. So the voltage output could be adjusted to 8 volts, but it is accompanied by change in current. Now, low resistance load, we shall change the value of the load resistance to let's see, to 800 ohms. So you change this to 800 ohms and observe the reading, new voltage output. So B out, record to B out, record the reading of the ammeter. Then next is adjust. Adjust again so that the output would be 8 volts. So this would become 8 volts, and this is the current. This is after adjustment. So that's all for your experiment number 3.